about to the question number.
We would like to challenge problem number 2, very like this.
Fail, reject.
Reject. We would like to challenge problem number 15, for type effects. Reject.
Sorry, I will talk in speech in Chinese。因为现在剩余的题目数只剩下5个了，所以现在开始开放问题。这个不好意思，那个你们还是，如果你们题目数那个小于4个或以下的时候，我们就会开始逐步开放问题。所以你们听到没说？
We would like to challenge problem number 4. Unthinkable list. Reject.
Now 现在开放问题13。
你们也可以看前面的荧幕哦，因为那个程式上面有看到那个亮的，就是你们可以选的题目。
We would like to challenge problem number 13. Turbine. Use that.
but we know that there should also take internal energy U into consideration, so we can calculate the compressible flow. We also know that the initial flow from the candle and the final flow from the candle should be the same, so we also set the candle as the datum length, so we can eliminate that part. Later, we change HF into L, which means the distance between the spiral and the candle. And this is the empirical equation. We can change velocity with some parameters, and W stands for the heat power from the source, L stands for the distance above the heat source, and C is a constant, which was between 1 and 2. And this is the ideal gas equation and internal energy equation. Here are other hypotheses. First, we assume that the initial air flow velocity is 0, which means we are observing the flow just from the candle and it has not been affected by the surroundings yet. And we assume that the pressure above the paper is enough, since we think that the flow above the spiral will not be affected by the candle so much. Later, we can calculate BF. This is how we calculate BF. We change the density and the velocity with the help of the ideal gas equation and empirical equation. After that, we arrange the equation and set the parameters again. After arranging, you can find the final equation of the pressure difference, and this is like that, and it is associated with some parameters, and we will focus on that later. This is how we calculate the total torque. As we mentioned before, there will be 3 forces acting apparently on the spiral, but we know that only the horizontal component force will affect the motion, so we should only consider the drag force and the force due to the pressure times some theta. This is the equation of the torque. We're going to discuss that the angular acceleration moment will consider moment on inertia of the spiral. Also, we know that there will be no angular acceleration in the end, which means that the force given by the pressure difference times some theta will equal to the drag force in the end. And this is the first discussion, angular acceleration. We know that this is the equation of the torque we have mentioned before, and we change the constant v in the equation of moment on inertia to the width of spiral over 2 pi. After arranging, you can easily find out that the equation of angular velocity is inversely proportional to the width of the spiral and the turns of the spiral. And we take in the equation that we have proved again, we can find out that the force of the pressure is associated with the temperature of the candle, the distance between the candle and the spiral, also the thermal power given by the candle. And this is how we calculate the terminal angular velocity. As we mentioned before, there will be no angular acceleration in the end, so we can arrange the equation again, and we can find out that the angular acceleration is associated with the temperature of the candle, the distance between the candle and the spiral, the thermal power given by the candle, and also the rotation, the distance between the rotation axis and the spiral. And we can move on to the experiment and discussion part. First, this is our equipment. We use trade paper, candles, and then shoot to easily reproduce our experiment. Then this is a setup. We fix the candle and then we shoot. Later we put on the spiral and let down the candle. And we observe the rotation of the spiral. And this is a top view of our spiral. For the variables, we focus on number of turns with spiral paper and also the different weight of spiral paper. As we mentioned before, we can find out that the angular acceleration is inversely proportional to the turns of the spiral and the weight of the spiral. So we are going to find the angular acceleration and the moment on inertia in order to get the torque. So this is how we calculate angular acceleration. We first check the angular velocity all the time, then we get a fitting picture. After that, we can combine the data in order to get a picture of angular acceleration, and we can further get the maximum angular acceleration, and we record that. So here comes the first variable, the weight of spiral paper. We use 2 centimeters, 2.5 centimeters, 3 centimeters, and 3.5 centimeters to do our experiment. And we found out that the angular acceleration will become smaller when the width of the spiral gets bigger, which means that the angular acceleration and weight of paper have negative correlation, and that fits our assumption. And we can move on to the moment on inertia. We have mentioned before that we use the mass we found out that the result of moment on inertia will get bigger when the weight of the spiral gets bigger. So they have positive correlation and the moment on inertia is proportional to the weight. And this is the torque of the under different weight of spiral paper. The result shows that the torque will also get bigger when the weight of spiral gets bigger, which means that the torque and the weight of paper have positive correlation. And this is another variable in terms of spiral paper. We use 3 terms, 4 terms, and 5 terms to do our experiment. And we found out that the angular acceleration will become smaller when the terms of spiral gets bigger. So that the angular acceleration in terms of paper has negative correlation. And that fits our solution again. For the moment on inertia, we found out that it also has positive correlation with the terms of paper. And finally, the torque will also get bigger when the terms of spiral gets bigger. So we prove again that they also have positive correlation. And we combine the 6 types of spiral that we have done, and we found out that the spiral with 3.5 centimeters width of spiral and 5 turns will get the biggest torque. And this is the equation of terminal angular velocity, which we have mentioned before. So we can find out that the experimental data and the theory are quite the same. So we get the conclusion that the number of turns and width of paper have a positive correlation to maximum torque. So here's another discussion. We can know that if we want to find the maximum torque, we should increase the width and the turns of the spiral. But the condition will only happen when the force given by the candle is still strong enough to make the spiral rotate. So when we increase the width and the turns, we will also increase the area, but the drag force will not change. At the same time, the force given by the pressure difference will change because when we increase the width and the turns, the circle may cover each other. So the force that is opposite to the direction of the velocity will become bigger and bigger, which means that the increasing rotation will become smaller, and that's the reason that stops the torque from increasing. So the torque will start becoming bigger in the end, and that's how we found the maximum torque. Here's another discussion. When we increase the width and the turns, we will also increase the mass. This is the equation of the torque. We found out that the moment on inertia will get bigger and bigger. At the same time, the angular acceleration will become smaller and smaller, and that is our experiment. The data shows the torque will get bigger and bigger. But at the same time, the maximum torque will be found before the angular acceleration becomes 0. Here's another discussion. As we mentioned before, we use ideal gas equation to calculate the pressure difference. But in real condition, we should use variable equation, which means that there will be a little bit difference between the real condition and the ideal situation. And this is another discussion in empirical equation. We want to find out that the equation is useful for our experiment, so we get the numerical of the thermal power over the distance and open cube group. So we use the machine to get the velocity of the fluid and we combine the numerical value. So we get the slope, and that is going to see. We found out that the coefficient of correlation is quite close to 0, which means that this equation is really helpful for our experiment. And we can move on to a conclusion. So conceptual understanding, we found out that the drag force and the horizontal component force caused by the pressure and difference of the torque. For the experiment, we found out that the width and the turns of the spiral both have positive correlation with the torque, and the maximum torque will be found before the angular acceleration becomes 0. Here are the references. Thanks for your kind attention.
So, starting with the first question, did you consider your setup to be in turbulent flow or laminar flow? Did you consider your setup to be in laminar flow or turbulent flow?
Turbulent flow.
Turbulent flow. Okay. So, what about do you think your phenomenon explanation can also describe the forces of which these spiral turns? Which direction these spiral turns?
Yes.
Okay. So, do you think that there will be a effect on the difference in theta as it's dangling down?
I'm sorry.
So you see that when the spiral is set up, the angle should be different in different spirals. However, do you think that the difference in theta would have an effect on the spiral?
Yes, but we do not consider that.
Okay. So then, according to your setup, I suppose that you only use one candle, which is put on the side, right?
Yeah.
So did you consider the unsymmetrical of the candle power?
No.
Okay. So can you tell me what torque you're trying to maximize?
The torque that makes the starter rotate.
So like for example, the torque created by the heated air or like.
We combine the three forces to get the total torque.
Oh, okay. So and you're trying to get that torque by tracking the data when it reaches the largest angular velocity. Is that correct?
Yes.
Okay. So and then can you please so for your setup, did you draw your? I'm not really sure about the drawing paper.
We use computer to draw the paper and
And then you just cut it out. And also, how did you set your spiral on top of the pillar?
just use hand to put.
Oh, so just put it right on. Okay, thank you.
不好意思，有帮我切换到。我们该是
a spiral on top of a candle and try to make it turn. And by that, we're supposed to maximize our torque. So the problem here that we're going to discuss about is how are we supposed to maximize our torque and how are we going to get our vision. So by summarizing so we'll first start with summarizing the reporter's report. So basically they gave, so they said that they're trying to maximize the torque of all three forces they analyze, which is the drag force, the pressure caused by the top here, and also the gravitational force. And then by that, and then they also use and then for their theory part, they use. I'm sorry for that delay. So they also use the Bernoulli's equation and also the ideal gas equation in order to calculate the torque that they're supposed to see. And then for the experiment part, they use different numbers of turns within the turning of paper spiral, and then they use different width of the spiral paper. And then they also in their conclusion they said that width has a negative correlation with the angular acceleration. So moving on to the pros and cons of the report. So they have clear variable explanation, and then they consider pressure, and then equation theory matches each other, and then angular velocity calculated clearly, and then they also put the actual theory, actual gas condition they take it into account instead of just using the ideal gas equation. And for the cons, they have definitions of positive and negative. They did not give clear explanations on positive and negative correlation. Like they did not explain enough, and then they did not consider the unsymmetrical heat wave of the candle, which can be seen in their setup, and then they did not consider the impact of turbulence, which they say is in their setup, and then they did not consider the friction between the spiral spin. And then so points to be discussed, phenomenon explanation. So first, we're going to have to talk about whether the setup is in laminar flow or turbulent force. So as we all know, laminar flow is a more stabilized force. However, they stated that their setup is actually in a turbulent flow environment. So I believe that there might be some misunderstanding in that. So maybe we can discuss about it later. And then we're also going to talk about the direction of rotation, just so that we make sure they understand their phenomenon clearly. And then also we're going to talk about the forces caused by the candle. So first, we all know that when the heat is trying to transfer its heat, the height would also affect the actual heat that is being transferred. But however, they letted that in their theory, and also the theta of the tilting angle of the spiral would also affect how much force is acted on the spiral, as they stated that F is actually something times sine theta. Okay, and then also we're trying to maximize the torque, so we're going to have determine about the definition of torque and how they're going to measure it. And then so for the experimental method, there's the stableness of spiral selecting parameters, and then that should be considered, that should be discussed in later. And then so for the parameters, we're also going to talk about like how much heat is being transferred, the paper materials, and then the geometry of spiral. And I would like to move into. Okay, thank you. So first, I would first like to start with talk about the environment that is in your setup. So as I just said, turbulent flow. That you said that your setup is in turbulent flow. Is that correct?
Yes.
Yes, but however, we all know that laminar flow is actually a more stabilized flow. While you're putting in, so laminar flows are more likely to go this way, while the airflow and turbulent flow might be not in a straight force. So that is, I think, maybe, and then when candles are exceeding heat, they would have they're supposedly to have laminar flow first, and then they have a turbulent flow. So I think by maybe controlling your height, you can you can make your setup inside the laminar flow area. Do you agree with me?
We have control at the same time.
Oh, so you control the same height. Oh, so what I'm saying right here now is that I think if your setup is actually in turbulent flow, it might not be as stable as you wish it to be. So I think that by maybe settling it down a bit, you can reach a more stable force, or either you have a misunderstanding in laminar flow and turbulent flow. Okay. Sorry. Yeah. Okay. So next, moving into the question. Let's say if I have a spiral which is turns in this way, how do you think this should rotate?
See how design is.
Yeah. Yes.
The
So for example, so this way, so it's should be turned like this way, right? Is that it? So it's okay, then we can move on to the next question. This question was just to make sure you can understand it in your theory later. And then also, do you think, so now moving on into the theory part. So first we're going to talk about height. So how did you assume the heat that's being transferred by the handle? Like, so I know you have a T final and T initial. Can you please explain that more?
So we can temperature of
Yeah. I think it wasn't really clear on that part. Can you explain it to me?
we didn't say that it will affect our total.
But I think it's in your equation. Can you turn to the part where you have your final equation?
We just doing this part.
Yeah, I wasn't really sure about the TF exactly, but please explain that to me.
Now we use a machine to measure the temperature of the candle, and initial means the initial temperature of the candle, and after the start becomes stable, and we measure the temperature again, and that is the final temperature.
So you're suggesting that there's actually a temperature change in a candle
Yes.
in time, and why do you think that is? Why would there? I'm not really clear on why would there be a temperature change in candle as time.
It is not quite associated with our group. I think I think the temperature is saying that also the temperature of the air.
Temperature of the air in what conditions? Like in particular points or in? I'm not really sure your definitions of those. If you're not really sure about it, it's okay. I just if I would suggest putting on like a more precise definitions on this one and that one, so that people can understand this one the definition more. But it's okay. We can move on to the other part where we talk about the tilted angle of the spiral. So can you please turn to your observation video? Okay, so if we can see right here that I think this part and this part, we can see that there's a significant difference in the tilted angle, in which that your force with the force which is caused by the pressure, the F pressure, is supposed to go this way, so it's related to the angle. But you said you did not take that into account. Is that correct?
Yes, because we just analyze the force diagram on a small area because
Yeah, I agree that you can analyze the forces on a particular small area, but however, when you take that into account of the whole spiral, each of the particulars theta may be different in the whole spiral.
we just assume that it is symmetry.
Oh, so do you think in that case you can still predict your maximum force with your theory?
I think there may be some error, but I think that would not affect that much.
Okay. I would say maybe add some correction to that term, and then maybe you can get a more precise number of torque that you're supposed to if you were to predict the final torque. And then moving on, there's some other questions that moving on into experiment. There's other things that I kind of want to talk about. For example, can you please tell me on page 21. Okay, so the variables that you try to use here is the number of turns with the paper spiral and the different width of the paper spiral. But however, the thing I was not sure right here was the what screw pitch mean, and also the PF, which I suppose P should mean pressure. However, it says right here that it's a final force.
And I zero, it means just the final pressure.
So it should be the final pressure. Okay, so then can you explain what screw pitch means? You're not sure about that? If you're not sure, then it's okay, we can just move into the next question. And for the, so while you're changing the varieties, for example, different width of the paper spiral, did you also consider that it might change the mass of the paper spiral?
Yes, we have mentioned that.
Oh, okay. So, do you think that, what do you think changing the mass would, so what would the mass, change in mass affect your final result?
And when we increase the mass, the moment of inertia will get bigger. But at the same time, the angular acceleration becomes smaller and smaller because when the spiral is heavier, it is harder for the force given by the candle to make it rotate. So it will, but our experimental result shows that the torque will still get bigger and bigger.
So, well, I mean, in that case, I think what I'm trying to point out right here is that if you're changing the mass, you said that you change the mass, right? You keep the mass same, or
It
different
will
will
have a little bit change.
so you think that's a minor factor of the total change? Okay, so now moving on into the next question. Can you please show me your result of the experimental data? Which you say you have the maximum total. So, and then the previous page. So you say that, if I'm correct, that you're trying to say, okay, so that might have been a misunderstanding. So it's okay, we can skip that part. And then I also want to talk about page 34. Page 34, I kind of want to make sure how you get the numerical of the thermal power. I'm not really sure about that because I think there's a lack of an explanation there.
We just get the thermal power of the candle.
Excuse me?
From the candle.
Yeah, like how did you get it?
We get the average number from the internet.
Oh, okay. So it might not be according to your experiment. Okay. So I think maybe we can try to find a way in order to measure I think maybe that's it. And then I think that is it of our time. Thank you. Okay, so I'm going to summarize the discussion. So basically, we talked about talk about the first is the environment in the spiral. So I still believe that the reporter might have some misunderstanding in which condition their setup is supposed to be and it's actually in. And so we also talked about like the height caused by the candle. The height that we change the difference as the heat transfer in different heights may be different. And then we also talked about how we change which the reporters say they didn't take it into account. However, we still believe that the feedstock, since it's really related into the F pressure that they're talking about, they should be taken account into the theory by adding a correction term or anything like that. Thank you.
On both judges and worthy opponents, I'm the reviewer of problem 13. And so the first question is for the reporter. Did you consider other air resistance, for example, vicious resistance?
I'm sorry.
Did you take other resistance into your consideration, for example, vicious resistance? Okay. How about for the opponent? Did you think that the other kind of resistance, for example, what I just mentioned, the vicious resistance will affect the result?
Yeah, maybe.
Okay. And the second question is for the reporter again. Did you consider the different number of candles? Because the different number of candles will lead to the different temperature difference and might affect the result.
We think that it will be different, but we didn't do that experiment.
Okay. And the next question is, did you consider the change of the density? Because the hot air and the hot air density is different from the cold air.
Yes, and I think that makes the convention.
So did you show this the density change in your calculation? Okay. And so did you put, because I heard you two are discussing about the TF and TI, and did you put the temperature difference into your consideration?
It is not our variable, but we just show that it is also associated with that.
So it will affect the result.
Yes.
And how about if you think it will affect the result, did you consider different colors of papers? Because if you use a black spiral, for example, it will absorb more energy.
No.
And how about talk about the is there any way to change the spiral diameter without changing the mass? Can you think of like probably one way? Okay. How about for the opponent? Did you think there is any way to change the spiral diameter without changing the mass?
I hardly believe there is, because mass, I believe that the area is what is related to the mass. So I think what you're trying to ask, maybe change the width instead of changing.
Probably you can change different papers, but
But that would change different papers, would still be changing the mass, maybe.
if you use the
I
same
got
mass. Honorable judges and worthy opponents, I'm the reviewer of problem 13, Kendall power turbine. And so first, talk about the main focus of what the reporter said. The reporter talks about main focus is talks about a different width of the paper. And second, he talks about a different number of She talks about the rotation and also she optimizes the torque. And I'll talk about what the reporter just said. First, she talks about phenomenon. When a candle is put under a Taylor spiral, it will start to spin like a turbine. And her theory is she calculates the moment of inertia. Second, she uses the ideal gas equation. And third, she mentions the convection. And fourth, she uses Bernoulli's principle to explain. And as for her experiment, she analyzes the three forces on the spiral. And also she discusses different parameters, for example, the different width of the paper and the turns of the spiral. And now I'll talk about the pros and cons of the reporter. First, I'll talk about her advantage. First, she identified the correct key questions of the problem. Second, she used clear illustrations on their theory. And third, she explains principles and equations in their theory thoroughly. And fourth, she considers ideal and real situation. And as for disadvantage, first, she did not explain that much for the outside factors that may affect the result. Second, the lack of the clear explanation for the result. And third, lack of different parameters. And fourth, lack of error bars in graph. And now I'll talk about the opponent's presentation. She talks about what the report said and the pros and cons. And now I'll talk about the opponent's pros and cons. As for the advantage, first, she suggested different parameters to be tested in an experiment. Second, she considered tilting in an experiment. And third, she summarizes the reporter's presentation concisely. As for the disadvantage, first, she brings several confusing questions for the reporter. For example, the center of mass. And second, the lack of experimental questions. And third, ambiguous response to the reviewer's question. And I'll talk about the discussion. First, the opponent asks, did you take the difference of the tilted angle into consideration? And the answer of the reporter is the reporter assumes that it is symmetric. And the reviewer believes we think we should really take the tilted angle into consideration since it might affect the result. And next discussion is the opponent asks, how did the reporter assume the height of the candle that affected the torque? And the reporter answer is, it is the temperature of the air that changes the candle's motion. And third, the opponent asks, what will the change of the mass affect the results? And the reporter answer is, the larger the mass is, the bigger the moment of inertia is, and the angular acceleration will decrease. And fourth, my question is, did you consider other air resistance? The reporter answer is no. And the opponent answer is, she thinks that the viscous resistance might affect the result. And another discussion is, did you put the change of the density into consideration? The reviewer answer is, they think that it won't affect the calculation. And the next question is that I asked, is there any way to change the diameter without changing the mass? The reviewer answer is, add some tapes. And the opponent answer is, this seems impossible. And their point is first, the parameters, different numbers of the candles, different locations of the candles, the mass of the spiral, different kinds of the paper, and also a left error bar for data, and the tilting angle of the spiral is considered the increase of surrounding airflow. Thank you. This is the end of my presentation.
This is a remark for the process. Right now, we have learned a lot more about this phenomenon, and we really appreciate the opponent and reviewer for the great discussion. This is a remark for theory. We didn't show about the variable of a theory, and we should be more familiar with it. Also, we didn't take the different angle of every single part of the spiral into consideration. Also,
temperature. How is it going to affect the experimental results?
Will affect the liquid velocity and the final pressure.
Well, I can't believe that the heat is generated by the candle. So the room temperature might affect on how fast the heat transfer. Because like if it's hotter or colder, it would change the difference in temperature in between the candle and the heat room surface.
I think it will affect the final temperature of the equilibrium.
Thank you. Okay. We show sculpture. Recorder. 7 8 Apollo. 8 7 8 7. Reviewer. 8 7 7. That is not 10 minutes.